Hey everyone, welcome to another session as part of Vedcraft series. In today's session, we are going to discuss about 12-factor app and how to apply 12-factor app in real-world application. So applying the 12-factor app principles in the real-world application is demand of the hour, and I'm pretty sure you must be already doing it, or you are partially doing it, or you're planning to do it. Let's look into the details of those principles and how you can apply it in the real world application with some examples. So before we look into the details of it, just step back and look at the principles, which was founded almost 10 years back by Heroku. And it's pretty much an industry standard now because of the clear nature of the thought process, right? It thought ahead of time in terms of cloud native, where you have pillars like DevOps, CD, containerization, and microservices, all acting as a pillar to enable 12-factor app principles in today's world. So those principles were founded with these foundations in mind. And you must have seen this website, or not, then I'm requesting you to go to the 12factor.net to read about those principles. So it has details of all the different principles along with some examples in terms of how you apply the principle. So our focus is not to discuss just the details about the principles, but also to see some examples of how you can apply those principles, whether it's code base, dependency, config management, and all. So these 12 principles in today's life is a must-have for any cloud native application. So the first principle is code base. And I'm pretty sure you must be already following it, but the key takeaway is that you need to ensure that if you're using microservices architecture, then you are keeping your services in separate repositories, not in separate modules in the same repository. So each particular service should have its own code base so that you can manage not only the code, also the deployment accordingly, and you can propagate the same image which gets generated across all the environments. In order to do that, the second principle, which is about the dependencies, which is again a very key part of it, where to make sure that the package management tool you use, apply and package management tool, and you must be using Maven Gradle if you're a Java developer, or NPM if you're a Node developer. But the package management, what it does is it brings together all the packages and put into the container, right? So, and that's why Helm as a Kubernetes has also started using Helm as a package manager. So do not put your dependencies outside the code packet. That's what the key essence of this principle is. You should declare your dependencies explicitly, and you should clear out all the dependency and package them using the package management tool. So pretty much in any modern practice development methodology, that's what is recommended as it was done like 10 years back. The third principle is about the configuration and the code configuration. And I'm just sharing an example when I used OpenShift in one of the programs where this principle comes out of the box if you're using Kubernetes per se. So the key tenet of the principle is that you have to keep the configuration out of the code, not inside the code, not in the YAML file, not in the properties file. Just use it as environment variable. And Kubernetes does it using the environment variable concept, which they already have, or config map. So you don't need to reinvent the wheel. Just use any Kubernetes standard compliant tool, and you will find this, the principle already implemented. So the fourth one is about the backing services. And the key tenet of this principle is that any dependency you have for the database URL or messaging system, email service, caching service, or anything, you just again keep it external. Do not keep it again inside the code base. You should access it via the URL and the ports and all, so that you can easily replace it. And that's an example for Kubernetes config map, right? You can maintain it in the config map and keep it external to the code base. It's again, if you're using Kubernetes, it's something which I consider out of the box. Kubernetes is built around the same. So pretty much you are implementing that principle if you are applying Kubernetes. The fifth principle is very important because Build, release, run, we often talk about these days continuous integration, continuous delivery, continuous deployment principles. So back then it was thought about the same thing, that your build process, release process, and run process, where you are starting from your code build to till the end where you're going live, and you can achieve by any CI/CD tool. But the essence is not the tool. Essence is whether the process itself is completely automated, whether you are converting your code repo to the executable binary and via the Docker images, and you're pushing it across different environments in the same consistent fashion. So tools, you can use any tools. These are just examples of some of the tools that I'm just showcasing here, that you can use Jenkins, you can use Sonar to quality check, and you can use Docker. But there are other options available. The essence is not the tool. Essence is that you need that pipeline, you need that approach and mindset, so that you can think about from build, release, run perspective. The sixth principle is about keeping the processes stateless. And stateless means you don't need to share anything. And it's a great example from Azure website, where they have talked about how to keep stateless, but still you need to save certain state. So don't worry about that. You can save the state by sending the data to queues, or sending the data to storage or caching system. But the essence is that that each service should be stateless, so that if you create multiple instances of it or multiple parts of it, then you don't need to worry about how you should persist the state. So Kubernetes again enables you to do that, but as an application architect or developer, you need to ensure that the services are stateless. So that's the key principle, and that we need to apply anyway in cloud native architecture. The seventh principle is about the port binding. And again, if you're using Kubernetes, it comes by default that each application pod is kind of labeled, and the port you don't need to worry about, because Kubernetes takes care of the port and IP address management. But you can consider kubeproxy is a way to implement that, which is out of the box. You're getting it, that it takes care of how you distribute load between different pods. So in essence, if you're using Kubernetes, this principle you're already kind of following. The next principle is about concurrency, and concurrency is to ensure that you have not the scale up architecture where you are adding more resources to the same pod, that adding memory or adding more CPU. It's about the scale out, that and I've represented in this XY axis, where you are suppose scaling out in different workloads. So I have a web workload, I have a service workload, I have a presentation tier workload, whatever it is. You should be able to scale up and add the same capacity to process more and more transactions. It should not be that you're adding more pods and it's adding more overload. So that's the key essence of the principle, that if you are following share nothing architecture, if you are ensuring that your application can scale up, not scale out, then you can pretty much achieve this principle. The next one is about the disposability, and disposability is again tied back to how you can dispose of the containers, and Kubernetes is a great way of implementing it, and Docker is a great way of implementing it. But as an application architect, we need to ensure that we should be able to shut down our application gracefully. We should be able to respond to, and you must have heard about the liveness check and the readiness check in Kubernetes, which can automatically kill the container if check will fail. But we have to implement those checks. That's the important part. And we need to ensure that the application is not designed that, the new container gets launched and it has some dependency on state management. So it should be able to handle such sudden deaths and all. So that's where the principle comes into the picture. And if you're following that simple, design principle of ensuring that you have enable liveness check and readiness check, production, application, and other environments as well, and ensuring that the application is not dependent on a state, that's what you can achieve this principle. The 10th principle, very important, and I've taken a reference from Harness, and I like this view where it's talking about how the dev and production environment should be in the same sync. Typically, the principle says that you can have a time gap, that you are taking a long time to create an environment, or you can have a personal gap where you don't have the knowledge of people that how the dev and product environments are configured, or there's a tools gap. You might be using some other technology in production and some other technology in dev. That is where you need to avoid, and CD pipeline or continuous delivery principles ensure that same. Although tools are there, you can use Argo, CD, Harness, Flux, and these are just some examples. It's the intention is not to showcase all the tools, but the essence is that as a process, you need to ensure that the continuous delivery pipeline, the example which you are looking at here, is followed, right? That when you trigger the delivery, it goes through a particular check. If the check passed, then you propagate it, and your dev and production environment should be as close as possible, or all the principle says it should be identical, not even close to, because otherwise it's not something which is you can easily create a cloud native architecture, because then the disparity comes in between, right? So that's a very important principle. The 11th one is about logs, and logs, and you must have heard of in all observability principles, is that whether it's logs, metrics, and everything, it's creating the whole the metrics, traces, and those kind of logs, so that you can treat logs as event streams, and you can use solution like Elasticsearch, which you are seeing an example here. But the essence is not the tool. Essence is that you have a process where you can stream the log. There is a log collector, and then there is a log visualizer. So in context of Elastic, you can use Kibana for visualization, or you can use Grafana. But the essence is you're sending logs to Fluent or some mechanism, and there's an aggregator, and then you can visualize the log. It's very important for production support people, because if they can't visualize, or if they can't visualize, they can't troubleshoot. That's the essence of the principle. And the last but not least is the admin process. So the key tenets, it says that you should have processes which you can kick off and run some admin task, and you should be able to isolate any problem. And there are languages which support that, and Kubernetes by default supports that. If you have used any Kubernetes dashboard, you can launch a terminal, and one-off terminal, and you can do the debugging in that terminal to view the state and anything. So that's one part of it. The other part is you can write your own small microservice like admin process, which can do some state of the application troubleshooting kind of application. So you can create those admin processes as well, which is very important when you're talking about SRE and production readiness and all. So these are the 12 principles which we have seen. And I know tools is one way of implementing those principles, but it's not only tools. And let me tell you that it's also dependent on how you're thinking about it, how you are designing your application architecture and all. So that's the crux of these 12 factor of app principles. And I hope you liked the session, and hopefully you are already implementing it, or you can take some takeaways from this session and start implementing some of the principles. So thank you so much, and looking forward to connect with you on Twitter or LinkedIn.